Hello, everyone. Welcome to today's webinar. My name is Erin. I'm a resident webinar host here at Softree. And with me today is our training manager, Matthew Dickey. We have a really exciting webinar planned for you for the next 45 minutes or so. It's on our SurveyMap module and P-line traversing. And this is a topic that I think it's been at least 4 years since we've talked about. And to be honest, what we're going to cover today is at sort of another level in terms of the depth. So for those of you who don't know, the SurveyMap module is the third module of RoadEng. It comes standard if you've done the RoadEng Resource Engineer or RoadEng Forest Engineer install. But it is available through all of our installers. You just have to use the setup button to get there. So the SurveyMap module is used predominantly for handling P-line data and P-line traversing. So today's plan, we're going to start off by talking a little bit about what is a P-line. Then we'll chat about some options for collecting P-line data. And the majority of the webinar is going to be focusing on a discussion of two distinct workflows. So the first of those workflows is sort of to say the more traditional one, which is where you use a P-line for both field reference for constructing it, as well as for the creation of your Topo data. And then the second, which is our sort of more modern workflow, is where we can use that P-line in conjunction with another data type, such as LiDAR, and we're using it for field reference and for construction. So we're going to take a look at those two different distinct workflows. Inside the software, we'll make sure we let you know when we're switching between them so it's nice and clear. So before we get into the meat of it here, a few pieces of housekeeping. To start, you are all muted per usual if you've been to one of our webinars before. We do encourage you though to engage with us and to ask questions. You can do so using the questions section of your GoToWebinar panel. So type them in. You do stay anonymous, so ask away, and we'll handle those at the end of the presentation. So with that, let's start by just talking a little bit about what a P-line actually is. So to start, a P-line is short for preliminary line, and it's a plotted line used to establish survey control so that a road can be built relative to it. So in forestry and resource roads, this is commonly the center line ribbons that you're going to see in the woods. But in practice, as I mentioned, we do have those two uses. So our sort of more classic traditional example from the pre-LiDAR days, and this is where we have that P-line, and you can see it here in the top right-hand corner of the screen. This is our P-line that's established to become our Topo data surface. And then we can use it for control for both the design and the construction of the road. And in the bottom corner here of the screen, you can see where the P-line is just being created for field reference only. So we're able to leverage a different type of data, in this case LiDAR in this image, and using that P-line for control when we go to construct the road, so just using it. So in either case, in this sort of post-LiDAR world, P-lines do have a lot of relevancy in our projects and in our road design. So with that, I'm actually now going to transition the presentation over to Matt, and he's going to take us into this sort of introduction into the P-lines in a much, much deeper detail. Matt, over to you.
Cool. All right. Yeah, so when we're referring to P-line or a traverse, usually, aside from just often using that process to get a Topo surface, we wanted to be able to relate what we're building to the traverse data set and what's marked in the woods. So if you look at that image to the left, that tree on the crest of the hill there, it has an extra tag on it, and that tag includes the station. So that stationing, our P-line stationing, is useful for when we go to build the road, rather than the builders having to, well, have either GPS with them or some means of survey control. They can look at the tag see that they're at station 650 or whatever it is, and then they can look at their design and relate that P-line station to where they're at in the design. So it's nice to know where you're at in terms of road length. Then the other side of it is it's nice to know where you should be. So in the two images to the right there, we can see the purple line showing up in those cross-section views. That's representing the P-line location, but we can see the designed road center line is actually off of that. So it's useful for giving us that relative measurement to those stations in the field to know our offsets and to help stake and build what we intend to build. Yeah, so that's common for both workflows, and we're going to start by digging into that classic traditional workflow of using a road traverse to get our topo data. So here we have a LiDAR surface, and this is going to be a little bit of a thought experiment. So we're going to pretend that we don't actually have this surface, but we're going to use it as a reference as we kind of step through this typical workflow that folks without LiDAR data will follow, or something similar. So if we were in the field and we knew we wanted to go from that low point to the high point and we didn't know where to put a road, well, we'd probably start by doing some walking around and figuring out where our control points are. So usually things like, well, your major crossings, if you have a switchback, that's tricky. So you usually spend a little bit more time figuring out where that should be so it doesn't cost you a bunch of money. And then if it's a grade controlled road, you're often going to be running grade lines to see where you can get to from those other control points. So you'll spend that time locating those control points. And then once you've got the control points flushed out, you'll usually go through and play connect the dots, I guess, in the woods, and fill in between those with the ribbon center line. So that ribbon center line really is our P line, but we need some means to well, measure it. So we go to the start of our road, and we'll usually collect cross-section information there. So we look perpendicular in either direction from our center line, and we measure out from that start station. So that start station being the center of that cross-section, and we measure out collecting things like slope, distance, yeah, and I guess that's the big one there. Once we've got a cross-section established, we'll measure from that first station to our next station. And here that next station usually is located either, well, as far as we can see, or somewhere in between as far as we can see and where we want to go to capture something notable. So usually that something notable is topographic features, but it could be other things like ground type changes, etc. So once we get to that second station, we're going to collect cross-section information again. And we're going to continue to do that until we get to the end of our road. So we end up with this 3D alignment with a bunch of cross-sections attached to it at the stations. So that right there is enough information to give us a surface. So we can approximate a surface from that. And going back to how we introduced this of, well, pretend we don't have that gray surface at all. We've just established all the P line, the cross sections, and the surface from it. And that's the surface that we're going to use to design our road. So that's that. Now let's, collecting the actual P line data, there's a few different flavors you can choose from. Kind of on the more advanced end of the spectrum. And keep in mind, this is more advanced end of the spectrum in terms of P-line. We can collect the survey data right in the desktop application if you're using a full Windows device like a Mesa tablet. So you can run the survey module on there. You can manually import your measurements, or you can connect it to either a GPS or a laser like the TruePulse 360 that we have shown in the image there. At the kind of the traditional end of the spectrum, well, you can enter all that stuff in a field book, and then you can enter it manually when you get back to the office. And then somewhere in between on the scale of complexity there, we have our terrain tools field, iPad and iPhone app, and you can do your data entry right in there to save your, well, save having to redo work by entering those notes manually a second time. We're going to start by taking a look at the terrain tools field app. So this is pre-recorded, just save the hassle of switching devices. But I'll talk through the process. So if we were in the field and we started our traverse, well, first we'd open the application. Then we'd click New Traverse, and we'd add in, well, a traverse ID or name, add a description if we'd like one, add a crew. And then in this case, the start of my road is actually the start of the road, or the start of my traverse is the start of the road, so I'm going to go with station 0. Here, the first thing that I'm going to do is an optional one. We could keep it in 0, 0 coordinates if we wanted to work locally, but I have an easting and northing to tie this thing down. So I'm going to enter those coordinates. And we could do this after the fact if we would rather do it in the office too. So we've got that start coordinate set. We'll go into our entry options here. We're going to choose to enter a 4-shot. We'll type out the azimuth that we're going from our first station to our second station, the slope distance that it takes to get there, and the percent slope between the 2 points. Next, we can add our ground type information if we'd like. And I'm going to skip culverts because we don't have any there. And then we'll go to the side shot tab. So at that first station 0, we're going to enter our slope information. So we'll go 40 on the left side and then -9 on the right side. We'll go on to the next station. We'll repeat the process. So largely the same, entering the parameters to get to the station 3. We'll enter our side shot information at that station 66. And here we're going to do that extended side shot entry where we're going -6 for 5.5 and then 150% for a bit to get up out of the ditch. And there we are. So pretty repetitive. I'm not going to do the whole road here live, but if we were done our traverse, we'd click that. We'd go back to export, and then we can send it to ourselves. So I just chose to send it in my email. And there we are. So that's quick intro in the Terrain Tools app. Next, I'm going to steal the screen here. And we're going to continue along with that example. But we'll enter it in the desktop app, and we'll talk about kind of configuring that to make it easier. So with that being said, I have our notes here just so folks can see what I'd otherwise be looking at in my notepad. And as Aaron introduced, if you have the resource version of the software, you'll have 3 icons, and one of them being the SurveyMap module. If you've installed the civil version of the software, well, that map module, the survey module, isn't going to show up as an icon, but we can get to it by just opening up terrain or location. And if we click setup, we can see, well, we can open modules, and there's our survey map module there. All right, so rather than starting entirely from scratch, which, I mean, we absolutely could, we could just click New Traverse and roll with it. I'm going to click Open, and we're going to continue along with our iPad traverse that we just started. So I'm going to open this IPD file, and there we are. Actually, So we can see we've got our information that we've already recorded. With this, if I want to extend this, I'm just going to double click this. So we have the option to extend. But before I start doing this, it's a really painful process if you have your notes in a different format than what's appearing here. And for me, so instead of using a station, I've got an index number being recorded here. Yeah, and I'm just using my slope distance rather than horizontal distance. So in order to avoid having to look at more information than I'd like, I'm going to configure this. So I'm right-clicking here, traverse entry options. Well, I want my field reference to be based off the index. I'll change my columns around here. So I don't care about my station. I want to see my index number. I'm going to leave type in here. Now I don't have it included except for these shots that are not 4 shots. So I'll talk about that later. I've got my 4 shot, which is my azimuth. I don't care about horizontal distance. I've got slope distance, slope percent, side shot left, side shot right, ground. I'm not going to worry about creek, so I'm going to get rid of that. And I've got my label. Next, as I enter this, I am a fan of not having to click each cell individually, so I can configure my tab sequence here. So I've got side shot left, side shot right first, then we've got our ground, then we've got type, 4 shot, slope distance, slope. So I'm actually quite happy with that. And then if I'm collecting my notes like this, I probably am doing it out of habit. And to save having to set that up every time, I can just hit save as default for new traverses. So I don't actually have to configure it each time. All right, so we are at IP3. So I've got my notes here for IP3. So we're going to start by entering our side shot information. If I go to my side shot tab here, I'll double click it. And we can, well, click each individual cell and say, well, I want to go minus 1% for 10 meters. And then we'll go 60 after that. And if I click draw here, it'll show what we're actually looking at in terms of that cross section. On the right side, well, we want to go minus 22. I hit tab to jump to that other cell, and we want to go minus 22 for 11. So 11 meters, I'll do shift tab, and then we'll go minus 8 for the rest. Now we'll notice here I'm not adding an extra distance. So if I just leave that without defining the distance, it extends it on for, well, quite a ways. We can change that and we can see that it's going on for seemingly forever. I'm going to hit tab. That jumps me through the options here. And to go from 3 to station 4, I'll type in 154. Next, I'll go 39.1, and we're going to go at that for minus 4. We'll tab in here. And here, I, of course, can go into that extended side shot entry by double clicking. But if I'd rather just type that out, and this is one of those things that it's fairly tedious to do, and if you're comfortable with it without seeing the graphic, well, you don't have to actually go into that extended side shot options to do what we want to do. So here we're going to go 12, and we'll put the // in there for 6. And then to switch to the next extended shot, we're going to have an asterisk / 35 over 7, asterisk / 7. So if I did that right, we can see it's actually showing the stuff that we want to see there. And you're not stuck one way or another. So I'm in there now. We'll continue this along. All right. Now, another option here And this is one of those things that I'm going to probably reference my notes to make sure I don't forget some of the stuff that I'd otherwise take for granted. In this cross-section entry, if we click options, well, right now I've got it point to point. So this 12% for 6 meters, if we go to there, we're measuring from that next point out 7 meters at 35% to get that. If we switched it to center line out, we'd be doing all of our measuring from center line. I've got it in slope distance, so we're measuring slope distance. And if we turn on edit extended depth, well, it gives us a few extra options. So if I define my layers at this point, so if we go hard pan over solid rock, and we say, well, that's 2 meters deep. With that extended mode on, we can make this independent of the other. So I can say that that's actually 4 meters. And we can see that rock surface is now running independent. Now I'm going to keep this simple, so I'm going to hit cancel there. Minus 13 for 11 and 1. Now, another thing worth mentioning, if we keep going here, let's just, if we decide, well, I want to, rather than entering each one of these ground types individually, we can go up here and we can assign our layers by range. So I'm not going to do it every time. I probably have splits at certain points. So we'll go from there to there, and we've got hard pan 1 meter over solid rock from 1 to 5. And there we go. So we've entered the ground type information as a bulk entry rather than splitting it up. And with that, it's, yeah, if I kept going, it would get pretty repetitive here. So we're going to close out of this, and we're going to open up a file that is almost done. We're going to talk about a couple more things here before we get into the design side of it. All right, so pretty straightforward. It's just a continuation of that same file. One thing to note here is most of those shots were being entered as 4 shots, so the azimuth. When I get to here at 6, I've got something else called out, which is an IFS. So if we're standing on station 6, what this IFS stands for is intermittent 4-shot, or intermediate 4-shot. So that is, our next station is up here at 7. And to get to that next station, we shot it at 175, and we want to head 31.4. So that point's known. But if you're doing a 2-man traverse, and this point is worth collecting, but it happens to run in the same direction as it does to get to station 7, well, to save having your rear person relocate up to that point, you can do an IFS where they stay in the same spot. You measure the distance there, the slope there, and then when you go to the next station, this takes the distance of that. And of course, with this, it's that intermediate measurement where that number obviously can't be bigger than that number because it's meant to be in between the two. Next thing that I'm going to mention with this file is, well, this file, if we do our survey and we make it out to the end, great. It's all measured explicitly relative to the last point. The tools we're using here are imperfect. There's people doing the measurements, that's imperfect. Inevitably, there's going to be some survey error. I'm going to just add in a couple columns here to see what we have going on. So at this point, I've taken a GPS measurement, and I've got my easting set as that, and they don't match up perfectly. And keep in mind, if I'm doing this, it's going to be a GPS measurement that I'm confident in. So if we take that measurement and we know our endpoint should be at a certain location, and we don't actually end up at that exact location, we can correct for it, and we can add in an absolute tie. And we could do that, since I've added the columns here, we could double click it to get in there. Or we can go up here and we can say, well, let's set get a tie. Now, before we do that, let's create a new map document. And so it's this one here that we want to use. So that represents our current alignment, or our current P line. Now let's save this as something new. And we are going to add a hard tie at this location. So set get, I want to make this absolute, and I don't want to shift my traverse. So by making this absolute and not shifting my traverse, it's going to keep the start station points that we've entered fixed, and it's going to take the points at the end here that we're fixing, and it's going to apply the compass rule throughout the traverse to disperse that error evenly. And I need to look at my notes here. So rather than this number, I'm going to type in 353.9 and 824.1. And I'm not going to apply an absolute elevation tie here because I don't have a good measurement of my elevation at this point. So we'll hit OK, and it tells me that we've got a 1.25% error in our traverse. And so we're going to save this, and just to get a visual of what we have going on there. Oops. We're going to add in that width ties. Oops. I didn't hit the button. All right, and we can see that now we've got that corrected, and it's taking it and it's changing things in order to fit that fit those hard ties. So in this case, I have a hard tie at the start, hard tie at the end. Everything else gets wiggled around, but you can add those hard ties throughout if you have good measurements on spots where you know the actual survey should be. All right, that's the main talking points for the data entry side of it. The next part of it is, well, making our design reference it. So let's dive into location. And so here's another talking point that we don't hit on regularly, and that is that if we're just doing a P-line traverse, well, of course, you can make a surface and terrain out of that P-line survey information, but it's not required. So I'm gonna not use a terrain file. I'm just gonna use a P-line traverse here. And I'm gonna go to this guy here. So I've got that. All right, and there we are. So we can see right now to start, our road is a carbon copy of our P line. So that is the L line is equal to our P line. Now I'm going to just speed through a little bit and have a reasonable design to work with here. So I'm gonna, well, in version 11, so I'm gonna use a new tool here. So rather than manually removing my IPs and adding in curves, I'm gonna do this here. And this is gonna take a moment to think. But this new tool is, well, taking a polyline, which the P line is, and converting it to an alignment where we've got proper curves being assigned. And the actual time it takes will depend a little bit on the problem complexity, but this one, it's thinking away here, and it shouldn't be too much longer until it gives us a really nice starting point.
While that one's processing, Matt, we're going to tackle one of the questions that's in the chat here, which is, can you better explain the difference between a P line and an L line?
All right, yeah. A P line is and of course we've been talking about the P line lots. It's the preliminary alignment, or the ribbon center line on the ground. The L line is the actual design line. So of course, and if you think to the example that we used in the introduction as an explainer there, when you're locating the P line in the field, I mean, you try to do a good job, but you're not really able to consider everything, all the nuances. So you have the P line as your preliminary alignment, but then as you work through the design process, inevitably the two lines aren't perfectly equal. And so with that, if you have little offsets here and there, the lengths are different. So your P line station and your L line station are different there as well. Yeah, and that might be more apparent here as we step through these next few steps. So that had run. So now we've got our curves at all of our, well, where it makes sense to have curves. I want to, and again, I'm gonna just cheat here. And rather than clicking in my vertical alignment by hand, I'm gonna optimize one. So, and let's go in there. We're gonna add a control point. And let's go with that. So, and all I'm doing here is just getting an alignment where we've got something a little more interesting than just looking at a line. So right now we're doing our vertical alignment using the optimizer. Oh, and I'm falling off the model here just a smidge. There we are. So I'm gonna manually adjust that. And again, if I was on it, I'd spend a little bit more time balancing that out. But we will we'll roll with this. So if we were happy with our design here, well, a big part of this process is in order to relate the L line to the P line. So if we zoom in here, we can see this line in the background. And this is a case where my L line, being this big magenta line that we have here, is different than the P line, which is showing up in black here. So a few things that I'd like to do so I can make my design relative to the P line rather than the L line. So I'm going to right click in my section options. In my header here, well, I have an option to show my L line station, my P line station, or my field reference. So I set my field reference to be the index number, so we can see we're at IP 38. Also in here, I want to show my P line. So here I'm going to do this. here in particular because we're not right on top of the two. So here we can see we're a little bit off. Great. If we want to make notes for actually slope staking this, we can produce a data table. So I'm going to configure this, data table options, point types. So usually if you're making notes for doing things relative to the P-line, a lot of the time you don't care about all these extra report points. We're going to only be interested where we have a station. So my P-line survey points are the stations we'd like to report. We're going to choose the information we'd like to report here. So we want to see it all relative to our index number. I'll leave these just to note the difference in length. But let's go in here and we'll go horizontal offset, and then we'll go down to our slope stakes, and we've got our P stake left and P stake right. So there we've got, down here we've got, we can see where our P line is actually 10 meters longer than our L station, and that's just those little incremental changes that we make as we round out corners and whatnot. We've got our horizontal offset, so right here I'm right on it, but if we go through here, well, at this point I'm 1.2 meters off, so we can get a feel for where we're a long distance off our center line, and we can use the P stake left and P stake right for staking our slope stakes. And then of course, for your documentation, we can put that together in our multi-plot editor. So I won't do a whole elaborate drawing package. I'll just do a cross section here, and basically it's the same thing as I showed in the other. We can show our P line, change the header if we'd like to change the header, and of course we can do in our plan profile, show those offsets, the data tables, etc. too. So that is our the classic workflow, and of course we can't just cover one. So we'll back up. I'm going to skim over the gist of adding a P line to a design that's based off of another surface. All right. So with that, I'll seal the control there back, and we'll go right from square one. I'll try not to go too late here. I notice I'm pressed for time, but should be able to do it fairly quickly. And I'm going to cheat here too. So train, if we were starting our project entirely from scratch and say we had LiDAR data, and it doesn't have to just be LiDAR data, but we'll bring in our survey data. So in this case, LAS files. I'm going to model that surface. We're going to save this. And then we're going to switch to location to locate our road. And in this workflow, it's not that we've walked around the hill and have figured out where we want it to go. This is very much the where do we think we should put a road phase of things. So we're going to click new file. And to start, I'm just going to use a single point, but I'm going to cheat here. And I'm going to, so if we were starting out with that, we could say, well, let's grab that initial point, we'll put it back here, and we could start clicking in and designing our road entirely from scratch. Now I'm not going to do that. I'm going to just cheat and add in an alignment based off a alignment that I've already got. All right, so if we went through that exercise and we landed on, well, this is the best spot to put a road, well, we can add a P-line in after the fact. And there's all kinds of ways we can do that. So we could figure out this is the best spot to put the road. And we could go figure out our start location. And this one happens to be on a built road. So nice hard tie. So we could take that and we could go the classic approach and use a compass, Clino, or laser to lay this out relative to that start point, kind of the same as the previous workflow, but opposite, where we know where we want to put it, we start there and we establish our ribbons that way. Or if it was a case where, well, we took this out to the field, maybe we export it as a land XML, or sorry, as an Avenza file or a shape file, and we use a GPS to establish where our station should be. Well, we can do that and we can convert those GPS points to a P-line. So let's jump back into this file. I'm going to click insert file. So I've got my P-line stations. I'm going to make a symbol visible here. So we've got all those points. Usually to collect your stations, it's nice to do it as points rather than like a track where you might be bouncing around. I'm going to join them into a single feature. I'm going to hit File, Save As, and we're going to change our format to be TR1. And now with this, I'm still going to use the LiDAR surface for all my topography information. So we're going to turn off side shots. We don't care about that. We just want the P-line here. So we've got that. And now we can go up here and we're going to add our P-line in after the fact. So gives us what it says is worthwhile. It's just says that to get the full functionality, you'll have to save and restart this. But the premise is the same, and let's find somewhere where we're. So there, we can see that P-line offset, and we're set up just the same as we were in the other one for all those functions related to P-line measurements. But our surface still uses the LiDAR surface. So with that, that is the gist of what I hoped to cover.
Awesome. 1 minute for questions. So let's try and tackle a couple. So the first question, Matt, that we've got here is, do you have suggestions to avoid falling off the model?
That one kind of is what it is. The big thing there was in the traverse side shot, I didn't collect it far enough out. So here, where I fell off the model, it was up here, and where I finished measuring my side shot would have been right on that steep spot, which is steeper than the fill slope angle that I had. So you can, measure that out further if there's a bench underneath you that you want to capture. The other side of it is, while I was falling off the model there, in reality, I probably don't want to fill down there anyway. So we can, well, in the case where I use the vertical optimizer, I should have put in a full bench constraint, because really I wanted to be in full bench through there. Yeah, or if you're designing by hand without the optimizer, just wiggle it around same way. You probably want to be in full bench there, so drop your grade so those fill slopes don't extend out past where they should be. Other things you can do is steepen up that fill slope if it makes sense, if you've got rock to stack rock. Yeah, all sorts of options.
Okay, with that, great content today, Matt. Hopefully everyone learned a fair bit about leveraging the SurveyMap module for traversing, as well as some tips and techniques and tools that you can use to make that whole process a lot simpler. So thank you all for attending today's webinar. Please do check out the upcoming webinar calendar that we've got up at softtree.com/free webinars, free-webinars, I should say, including next week. We are doing a webinar exclusively for support subscribers. So you do need to be on support to get access to it. And it's all going to be about borrow and waste site design and how to integrate that in with your road project. So another pile of great content coming next week. And with that, have an awesome day, everybody. You'll see this video up on YouTube soon. Thanks.